Also a reminder to girls basketball that bus time is 4 o'clock.
I reminded everyone in the locker room too.
Hey, 4 o'clock.
Yeah, we finished in 5 hours.
If you have any old assignments that you want to turn in, remember they're due by Friday this week. If you have like an M in the grade book, that means it's missing. That means you got to turn it in. Things that have already been turned in as of this moment have been graded, so they're in the grade book. Page 41, 47, 56, that'll be going in hopefully today or tomorrow. So if you have not turned that one in, that was the one that was due yesterday. That one will be going in. All right, hopefully you figure out scene arrangement. Let's see, we're using Michaela today. Okay, so let's go through a couple notes here. All right, you need to have your practice guide out, please. Practice guide out.
What players in my mind?
Your practice guide.
Oh no. I was saying totally the wrong thing.
So, all right. So, practice guide, chapter 2, yesterday. I figured it was passing here. All right. Let's see. Yesterday we talked about 1 through 6 in your practice test. Does anyone still need that? Everyone got one? Okay, good. All right. Yesterday we went through 1 through 6. Remember, when we got to number 6, this was kind of a weird, obscure problem where, where you had to, you had to know, there's only one Chicago in the U.S. If it's something, randomly obscure, I'll kind of give you little hints when you're taking the test on the test day. It'll be some obscure little note that will help you hopefully figure that out. I think the ones I picked are pretty straightforward. They're obviously, they're obvious. So, remember, on number 7, the first thing you got to do is you got to figure out which part's the hypothesis conclusions. You got to underline it, circle it, whatever you do, put the H and C next to it. Then you have to tell me if this sentence is true or false. And if it's false, you have to give me a counterexample. Counterexample means this part's true, that part's false. So you maybe draw a picture, maybe you just explain in words, you can do something. Maybe you're showing some math that's involved, that type of thing. Okay? So you're going to have to think outside the box. Okay? All right. Any questions with 6 or 7 that we talked about yesterday? Now remember, 6, we talked about this part was the hypothesis, because it follows the word if. This is the conclusion, it follows the word then, so that's the first part we did. And we said this statement is true for the U.S. only, because we're talking about U.S. This is true, and the reason why I would explain, there's only one Chicago. There's one city that's named Chicago in the entire U.S. Thinking about worldly, there is, I think, 2 or 3 Chicagos. There's a Chicago in Mexico, there's a Chicago in Guatemala. But no one's going to know those random places. But for U.S., we can. All right, moving on. Number 8. Okay, this one we have to write the converse and contrapositive. Okay, so converse is where you switch things around. Okay, so I'm going to make up a sentence. So I'm going to make up a sentence that looks like yours, so that way you can do it for yours and you can see two examples here. This is the one problem I don't have like two of them. I can't. Okay, there we go. So there's not two of them. But I'm going to just make one. If you are cold, then you should wear a jacket. Okay. Alright, so there's my sentence. It's an if-then statement. This part is the hypothesis. This part is the conclusion. Now, what we need to do is write the converse and then the contrapositive. So if you don't know what converse is, all you're going to do is you're going to switch these words here, which is the hypothesis, with the conclusion words. So we're going to switch the hypothesis and the conclusion. You're going to leave the words if and then where they sit. So we're going to leave those words exactly how. So here's my sentence now. If you wear a jacket, then you are cold. Okay? So you see how that works? I moved the wear a jacket up front. I put the cold thing in the back. That's a converse. So this is the converse of that sentence. Okay. Any questions with the first part? What you have to do? Notice I left the words if and then where they sit. I just switched the hypothesis conclusion. Or it's all over if and then. Now the second part, you have to write the contrapositive. So if you check your book and you look up contrapositive, it says that you need to negate the converse. So, in fact, the contrapositive was one of our vocab words. So if you look back at the vocabulary we had, it says that you're going to take this statement, you're going to write the converse for it, and then you're going to negate both parts, the hypothesis and conclusion. So that means when I write the contrapositive, and I'm just going to do a quick modifier here. So now I'm going to write the contrapositive here. And you should be writing the second sentence. You should have two sentences when you do yours. So contrapositive. So I'm just going to write right here, come out the space. If you do not wear a jacket, then you are not cold. That, right there, that is the contrapositive. I'm putting the word not in front of the, in the hypothesis and the word not in the conclusion. Okay, does that make sense, like how you do that? Now if I ask for an inverse is you take the original sentence and you put the words not in that one. That's an inverse. So like if it does not snow today, then school will not be canceled, that type of thing. That's an inverse where you negate the original statement. You need to look at the book, check out those sections. I believe the section was like 2.5 when we started learning about conditional statements and all these different forms like contrapositives, converses, inverses, that kind of thing. Okay, questions, comments on number 8. Now obviously I didn't do your number 8, I did my own, but you guys get the idea. You should have two sentences. You should have the converse and you should have the contrapositive. Question?
Does it matter contrapositive? Does it matter if you get like the original sentence or?
Contrapositive has to be the negation of the converse.
Okay.
So, yeah. So that's why you have to write the converse first, then you write the contrapositive. Yeah, good question. Any other questions? Okay. All right. Let's move on. Okay. 9. All right. For number 9. This is the one where they're testing your knowledge on those postulates we had. All the postulates from postulate 2.1 all the way up to, I think it was like 2.7, where, certain lines and planes are interacting, that type of thing. So these are the ones that are really testing your knowledge. So the idea is that you need to make sure you write all your postulates, all your theorems on that property sheet you have. That's the one with, deduct, or not, the reflexive, commutative, distribution properties. That property sheet, you can write all the postulates and theorems on it. You can't staple anything to it. The reason why you're going to need that is
Kaylee
this.
Walstead come to the office, please? Kaylee Walstead.
This problem, you definitely need those postulates. Okay, so when we look at this problem, I'm going to just pick 2 of these. So which ones do you want me to do? Just pick 2 of these. So 1, 2, 3, or 4. 1 and 3. Okay, let's do those 2. Okay, so the idea is that I want to know. The idea is that which postulate shows that this statement is true. This statement is true. Wrap your head around that. It says that. State the postulate that can be used to show why this statement is true. So don't tell me it's false. Okay. So the statement is true. M, K, and N are co-planar. They're on the same plane. Well, that postulate 2.3, and if you look up 2.3 in your book, in fact, I'm going to read it out loud for you, it states that through any 3 points, there's one plane. In fact, let me give you the page number so you can see those in case you lost your notes or you have very disorganized notes. Actually, it's 2-2, sorry. 2-2, not 2-3, 2-3. There's 2-2. Through any 3 points, there is exactly one plane, and that page number, by the way, is 127. So, through any 3 points, there's one plane. And now N, K, and N. M is up in the air, N is here, and K is there. There is a plane that touches all of them. You can tilt planes in such a way that it hits all 3 of them, because they're non-collinear. Okay, moving on. N and K are collinear. That would be postulate 2.1. For any 2 points, there's a straight line. Now, if they start asking like where are these lines cross, that would be 2.6, or where planes cross, it's 2.7. If they want to know why this certain line is on a plane, why is this line on the plane itself? Because that's 2.5, that type of thing. 2.3 and 2.4 are just kind of a mixture of these 2. So you need to have those postulates written down. You need to know the idea behind them. Okay, these 2 say, like when you're given the points, there's a plane that touches them, or when you're given points, there's a line. There's ones that say if you're given a line, there can be so many points on it. That'd be 2.3. If you're given a plane, there's so many points on it, that's 2.4. So you gotta know your postulates. Okay, questions, comments, and what I'm testing you here. Okay, moving on. Let's go to number 10. Okay, this one. You have to prove the following problem. You have to give me every line of work, every step. Okay? In fact, I'm going to do the first couple lines for you, just so you can see like how intense this needs to be. Your problem will not be so difficult. Now, what type of problem is this? Is this an expression or equation? Equation. Okay, now typically equations take about 4 lines of work to get rid of every digit, right? But this problem starts off a little difficult. If you notice it, it's got distribution in it. So we got to do that first. So we can't just start solving right away. So we have to distribute. You got to move things around and add them. This problem takes, I think, it takes 3 lines of work to do distribution. It'll take another 2 lines to get down. I'm thinking this problem could potentially take 12 lines of work. I'm going to do the first 4 or 5 for you, so you can see it, and then you can know how to finish it from there. Okay, does that make sense? Now, your problem will not be so difficult. I mixed everything here, so like there should be no surprises on the test. The test problem could be an expression or an equation like this. Equations, you got the properties of equality that we use. Expressions, you just use distribution, substitution, all that. Those you don't have so many properties on expressions. Okay, so I'm going to do this problem for you, just so you can see it. So the first line, I need to distribute the 4. In fact, before I even start, I'm going to put a 1 here. So that would be the multiplicative identity. Multiplying by the number 1. I need to put a number in front of that letter X. I don't like the fact that they left it out, so it should be 1. Alright, so the first step, let's distribute the 4. So I'm going to hand the 4 to the 1x, and I'm going to hand that 4 to the 3. The 5x, I'm going to leave alone, and that 24 I'm leaving alone, but all I did here was distribute. This is a 2-column proof, if you notice. I'm doing two columns. I'm doing the work on one side, doing all the properties on the other. That's why you need your property sheet. Okay, so now that I distribute, the second step you should always do after you distribute, I need to do associative. I need to move the parentheses. That's associative. For some reason, some people in this room think associative is used for everything. It's only to move the parenthesis bars. It's not distribution. It's not that. It follows distribution. When I'm checking those property sheets, worksheets 2-6, I had some people that put associative for like every other property. You're using it way too much. You use it very rarely. In fact, this is the one time I actually have to use it after distribution. All right, next, I'm going to do some math here. This is a multiplicative identity, taking 4 times 1. So, multiplicative identity. The next line is substitution. I'm actually going to multiply 4 times 3, which is what, 12? So that's substituting, doing simple arithmetic in the middle of a problem. That's not multiplying by 1 or adding 0, and those are special. So now I've got rid of the parentheses. I got rid of those first starting points. Now I need to combine the variables, and then we can start solving this problem down like a normal problem. If this problem didn't have an equal sign on it, this would be a normal expression. This is basically the steps you do for expressions. You distribute if you have distribution, you associative, you substitute, and then you combine variables after that. So moving things around, I need to move that 4x and 5x around. So moving these the variables, the 4x and 5x around, that's commutative. It's commutative, moving things around. And now this is the part that on your worksheet, the worksheet 2-6, this next line that I'm about to do is the number one problem that people make mistakes on. The number one thing, if I thought, like, of all 65 geometry students, 57 of them missed this. Just this one step. When you add variables together, you actually have to take the x out by distributing it out or factoring it out, like this. That is distribution or factoring or reverse distribution, whatever you want to call that. For some reason, people think it's associative. No. It's not associative. Associative is when you have parentheses and you move them. There was no parentheses in this previous line, so I'm not moving them. So the simple fact that I took the x out is the distribution or factor. So that's distribution, and now the next line I can substitute. So this would be 9x minus 12 equals 24. That would be substitution. This right here, what you're looking at, other than the stupid multiplicative identity property, like distribute, associative, substitute, move things around, distribute, substitute. These steps are usually what you do on expressions, not equations. From here on out, now we have to solve. Question?
If the bottom distribution, can we put factoring down?
Yes, you can put factoring or reverse distribution. Yeah, I accept that. From here, I'm going to leave the rest of it for you. Now it's a normal equation. So now you're going to add 12 to both sides by adding the property of equality. You're going to substitute the right side. You're going to add the property of opposites where the 12s cancel on the left. You'll have additive identity. You're going to add 0, so now you have 9x equals 36. Then you're going to divide both sides by 9, which is division property of equality. You'll get a substitution on the right side, which is 36 divided by 9, which is 4. And on the left side, you have a reciprocal property, makes 1, and then you have to multiply the 1 on the x, which is x equals 36, and that would be multiplicative. So I just literally gave you every single property you're going to use. There's 8 steps left. Okay? You need to look back at the notes. Every time we do equations, they're the exact same lines. The only weird part is I made this problem difficult in the beginning because I wanted to review how to do expressions as well. Like this is an expression to begin with. And then after this, I'm going to solve the equation. Okay, any questions with how I started that problem? Now, obviously, yours not going to be this hard. I made this problem so it covers like literally every property you had in that whole property sheet. Had commutative, had associative, had distribution, had properties of equality, had identities, had property opposites. I literally made this problem so it had every single property known to man. The one on your test will leave something easy. So you have to do all the steps. And trust me, you have to have the property names and the work. You get points for just work. You get points for properties. So if you're ever in that mode where you're getting stuck, at least do all the math correctly. Because you should be able to solve that problem no problem. At least showing me some steps. Okay, questions, comments? Keep going on that problem. So I did more than half of that. Okay, let's move on to 11. Anyone recognize this problem? It's in your homework? I did it in notes one day as well. It's on the PowerPoint. So this will be the third time you're going to probably see this one. Because you just did it in your homework on page 147. It was like number 2. Okay, so I've done this. This will be your third time seeing this problem. So, how do we sort of prove? Given. Well, what we're given, line number 1, Wx is congruent to yz. That was our given, that's our reason. 2-column proof. Okay, so that's our first line. Line number 2, you should always redefine what does congruent mean. What does the symbol mean? Equal. So Wx, that stick, is equal to yz. In fact, I'm going to mark that on the picture as the definition of congruent. Wx and yz are the same. Okay, so now that we have that stated, those first couple lines are always kind of about the same. Line number 3 is the tough one. This one, what you need to think about is like, what are we trying to get to in the end? Like, what are we trying to get to? We're trying to get to that this stick here is equal to this stick. Wy is equal to xz. That's what we're trying to get to in the very end. Those two pieces are the same. So that should be like my line 5 or 6, somewhere down the road, wherever it is, line 4, I have no idea. So what I'm basically going to have to do, at some point, I'm going to have to add these two sticks together to make the whole stick. I'm going to have to add these two sticks together to make the whole stick. So I'm going to need to introduce the stick xy. Xy was used in both pictures. It was used on this left side. It was used on the right side. So on line number 3, xy is equal to itself. That is reflexive. Now the reason why we do that in geometry, why we do that for a property, is I'm going to introduce it. I'm introducing that xy, that stick is the same stick in both pictures. And now what I can do is I can add that to both sides. I can add this xy to both sides of this statement. So wx plus xy and yz plus xy. I can add these because it's a property of equality that I can do this. So in line 4, I'm going to add that up. So wx plus this little piece and yz plus this piece. And that is the additive property of equality. Adding to both sides. Something that's equal to both sides. And what I'm going to do on line 5 is I'm going to write what is this according to the picture. So I'm like defining what these little pieces are right in line 4 or in line 5. So on line 5, and I'm almost done. So what is wx plus xy according to that picture? Wx plus xy, what does that mean? 1, right? And the other piece, this piece here, yz plus xy. That's yz plus xy. What does that make? xz, right? And all I'm doing there is segment addition. Adding the segments together. Make bigger ones. So I'm just defining what those pieces are. And now the last step, what I'm going to do here on line 6, I'm going to plug these things that we just figured out, like what this thing added up to be. I'm going to plug this right here, plug this right here, because that's what we just said. We said these pieces are equal to these two things. So I'm going to substitute those in. So this line number 6, I'm taking out this blue part here, and I'm plugging in WY right there. And I'm taking out this blue part and plugging in XZ right there, which is what we want, right? So I'm substituting. Like that's how you're supposed to do that problem. I mean, that's literally what we're trying to prove. And your last line, like I've done this again, it's the third time seeing this. The last line is, instead of writing that they're equal, I can write that on line 7 that they're actually congruent to each other. That WY is congruent to XZ. That is definition of congruence. That's the property you use. And that's what, actually what we're trying to prove. So dot, dot, dot. That's what we're trying to prove. You can do the same exact proof for angles, angle addition. You know, you have a bunch of angles that are being added together. You can do angle addition, plug them up or equal, substitute definition of congruent. What you're going to have for the test, it will be some easy geometry proof. This, I consider this one actually not hard. It'll be something simple that you have to prove. You know, it could be something as easy as an algebra problem. Like, oh, these two pieces are equal, so show why x is 12. You know, that's the type of problem I could give you. But you have to give me the statement reasons. Kind of like what you did at number 10. I just picked this problem because it was one for your homework and you've seen it before. So you can kind of tell, like, it's going to be something you've seen. I'm not going to make it something difficult. I think a really good problem to put in this spot would be like when it comes from page 141 to 23 through 26. Those would be really good problems to put here. Because those are like algebra problems. So you have to know how to basically kind of solve those. Okay, questions, comments on how to do that? Okay, let's move on. Let's go to 12. This is the last problem of the day. And I'll give you some time where you can just kind of work on this. Okay, 12. All right. So the idea on this problem, they're giving you a hint. This is your hint. That's the picture. What I want is I want to know what your angles 5 and 6 have to be. So like I want to know what numbers they are. That was, by the way, this problem is from page 156. I believe it was number 8. So you have to find the angles for 5 and 6, and then you have to tell me like what was the main property that you did here, and like what was the main reason why you know this is true, that type of thing. And I can think of just a couple properties why this does work. Okay. Now, so if these angles are the same, 5 and 6, I can mark that on the picture. So these angles are the same, right? So I can pick any variable I want, but I know that they're going to be the same angle. So this can be x, this can be x, whatever those numbers are. So what do all 3 of these angles have to make? 180. That's one way you could approach that problem. Okay, that's probably the way that I would do it. And so you have a couple x's here added together. You have that. What is this angle here? 90. This has to equal 180, you add them all up. Now you can solve for x. This makes 2x, you can solve. The idea here, what you're doing angle addition. That's, it's angle addition postulate. What is that postulate? 211. Another property that we're doing here, we're doing theorem 2.3. Theorem 2.3 was, it was called the supplement theorem, just so you know. Supplement theorem says that you can add angles to make 180. You could have, this could have been theorem 213, which is called a linear pair, right? Do you agree that all 3 of these angles make a straight line, a linear pair? it's whatever property, like, what was the main thing you thought of? Oh, I thought of, like, English. I'm adding English stuff to make underneath. That's what I thought of. But you have to solve. You have to actually figure out what those angles are. So it can be any picture, you know, I'm going to pick one from probably 156. You just have to give me what the angles are. I'm not going to make up something incredibly difficult. Just something where you can actually solve for the missing angle. This will be your clue. This will be the picture, and you use it to figure out what angle 5 and 6 or angle 1, 2, 3, whatever it is. Okay. Questions, comments on how to do that problem? You will definitely need a calculator on that to like figure it out if you don't know. I think it's pretty straightforward. We'll definitely need a calculator for this. All right. Your goal today. Try to finish up this practice guide. That's like goal number 1. Try to finish it. Try to wrap it up. I've done most of these problems for you. So you can kind of get a glimpse of like what you're going to need to be able to process. Remember, don't memorize these answers. The test is different, right? I picked a different problem from the book, put it in a spot, something similar but not exactly the same. You need to take your property sheet if you have them. Let me draw this real. Okay. This property sheet looks like this. And this is the property sheet. It had the properties of quality, had the field properties, had the back page. You need to have that. You need to start writing your theorems on them. So like postulates 1 through 11. Your theorems 1 through 13. And they have to fit. Now, if you don't have that sheet anymore, I don't give you a new one. You've got to go to my website, hsmath.org, and reprint it out. You can go to the library and print it. Question?
Are we supposed to do it like proof, like instead of solve test?
No, just solve the numbers. Just solve it really quick, and then just tell me what was the main property you used. Just 1 or 2 properties. That's it. It's not a proof. Okay? Make sense? Okay, if you have not turned in late work, like page 141, 147, 156, get that turned in so I can grade that. If you have any other like M's in the grade book, get those done. You have the rest of the time to kind of work today, which is about 10, 11 minutes. Okay? All right, there you go. When is their test? Tomorrow. Their test. The test is tomorrow, so make sure you're reminded of that. Do not lose your practice guide between now and tomorrow. So it's always comes like, oh no, I left it at home. Yeah, you should bring it. You know the test tomorrow. Do not leave it out on that.
I'm just writing down my theorems on my paper right now.
Circle, here you go. That was in the green book. I should pick name on that the other day. And then go to yours.
Are we allowed to write like an example of the theorem?
Here, like if you have the diagram that goes with the.
Yeah, okay, that's fine, okay.
As long as you have your theorem written in there.
Okay.
So.
attention, please. Joe from Athletico is here. If there are any freshmen or sophomores that need to see him, please go down to the locker room area at this time.
Let's get over there plenty early. So, I think Lau sent out an email this morning or something like that.
Yeah, she was.
You didn't get the email?
No, are we supposed to like change and ready to go, or just like?
Just get on those. Just have everything packed and
Okay.
ready. So that way we have some time to change the lessons, you know.
Yeah, that's what it is.
I enjoy this class.
Yeah, I know, that's why I said that.